So it has incentives. That means it has real life consequences. Okay. And now the dictator game that I've kind of almost mentioned in the discussion of hypotheticals as an example of how to do stuff better. Let me explain actually this as an example of an incentivized decision. How does it work? So the dictator game, as the prisoner's dilemma that we discussed in the very beginning of this lecture, is an economic game. So a small little situation where we can have some people involved and have specific options of what to do. So let's say you have 10 euros. I, the experimenter, give you 10 euros. And now I tell you, you could share these 10 euros with one of the other participants in this course. So you would be matched with another participant. And this person has nothing because you are the only person that I gave 10 euros to, right? So my question to you is, do you want to keep the 10 euros or do you want to give something to the other person? And then now, for this to be an incentivized decision, what I would usually do is actually bring these 10 euros to class and then pick two people and actually play this game. But because we're online, I cannot do it. So you have to imagine it, which sort of defeats the purpose of an incentivized decision. And I'm sorry about not being able to do this better, but you're just going to have to play along. So the idea of incentivized decisions is that actually we put the money on the table, figuratively speaking. So people are playing about real money. So in the end of our experiment, they get to take home whatever they decided to keep for themselves, and whatever the other person got, they will also get to take home. So that means you now would go home with actually 10 euros in your hand if you decided to keep them for yourself. Or you would go home with 5 euros in your hand and the other person also gets 5 if you decided to split it equally. So that is the idea behind incentivized decisions, that indeed we pay you the money that this is about, or we enact your choice, whatever that choice was. So what can we, if we take a look at some data about how people make decisions in this kind of situation, what can we see? This is data from a big meta-analysis. You can see there's quite a large sample size involved. I think this is about 20,000 subjects. And what we can see is here how much people give. This is a percentage, so do they give all, 1, or nothing, 0, on the x-axis. And on the y-axis, we can see the fraction of choices where this was the case. So this is a histogram. Okay, and what do we see? Well, we see there's a sizable portion of people who give nothing. Right? So about 36% of people just give no money. And this is what would be in line with our expectations from expected utility theory, right? Those are the people who just are selfish and they just maximize their own outcomes. They keep the 10 euros to themselves in our example. We also see on the other extreme that there are some people who give everything they have to someone else. And well, so they give all the 10 euros to the other person involved in the game. And we can see also there's another point that kind of sticks out, which is the 50-50 solution. So I keep 5, you get 5. And it seems like there's a strong norm to choose this actually fair choice. And we can see that there's a bunch of stuff in between. So some people just give 1 euro away, so at least they're doing something. Some people give most of the money away. And what we can see overall is that we do see more people actually giving something than we should. We should see no one giving something. So this is just to reinforce the point of the expected utility theory that we discussed in the beginning of this lecture. Okay, so we've seen that people actually make pro-social decisions in our dictator game. But do they always make the same decisions? Or is there like a way we can influence people to be more or less pro-social? Actually, if we just stay with the same study, there's some information about moderators in there that we can now take a look at. So one of them is clearly whether you know who the other person is or you don't. So if in this course we do this game and I tell you just one anonymous other person, I'm not going to tell you which one, will receive the money that you give to them, then it's less likely that you will give a lot compared to when I say, it is the person who's sitting next to you. You're making a decision to split the 10 euros between themselves and you, this literal person who's sitting next to you. Okay, and clearly in the second situation you are going to be more prosocial, and this is also what we see in the data. This is what you see in this graph here, where either the receiver is identified or not identified. There are more moderators though, and we can take a look at them here in this graph. This shows us the significant regressors in a complete model of a meta-regression. So this is all these 20,000 decisions that we looked at before in the aggregate. And then now we're taking a look at what predicts whether people will give more or less. If this is a positive predictor, positive regressor, then we will see that it goes to the positive on the x-axis. If it's a negative regressor, so it decreases giving, we will see it go to the left of the x-axis. And what can we see as a positive predictor? What makes people give more? Well, being older does. People who are older are actually willing to give more in our dictator game than people who are younger. If there are multiple people who are the recipients of the money, then people are more likely to give than if there's only one person. If the recipient somehow earned this money because of something that they did before, people are more likely to give. If the recipient is deserving because they are poor or they've had a bad day or some other reason that makes them deserving, people are more likely to give. And if it's efficient to also to give, then also people are more likely to do that. For instance, if people are making the decision in a group, then they're less likely to give money, or they give less money. Also, students and children give less money. Student status is associated with less giving. So these are some predictors for how much people will give that we can take from this study. Here is another example of a game that we could use to study decision making in the realm of prosociality, and there's only a slight difference compared to the dictator game, which we just discussed. And this new game is called the ultimatum game. And here the difference is that the recipient, the other person in this game, actually has a choice to say, well, no, thank you, I veto this. So again, you get 10 euros. And you can choose to keep these 10 euros to yourself, or split some amount with the person who would regularly sit next to you in the lecture hall. But this time, the person can refuse your offer. They can say, nope, that's not good enough, and then you both go home empty-handed. So in that case, you don't get to keep the money, right? But if the person accepts your offer, then it will be enacted as you suggested. So then you will get to keep what you decided to keep, and they will get what you decided to give them. So the twist here is that, now it's about actually meeting some kind of an expectation of the other person. Right? Because, again, expected utility theory would actually propose that every of the recipients should be okay with any amount, because it's better than nothing. If as a recipient I get 1 euro, I should be okay with this because it's better than going home empty-handed, having no money. But actually we see that many people are using their veto power and say, well, 1 euro, that's not good enough. I'm going to take away your 9 euros and we're both going to go home empty-handed here. And then we actually see many more offers of the fair distribution of the 50-50. So in ultimatum game is also an interesting way to study pro-social behavior. Another one, and this one is a bit more complicated, is the public goods game. So in this situation, we have 4 players, and each of these 4 players is endowed with or has 10 euros. And they can decide to contribute their 10 euros, so just put them in the pot. And there's so basically there's a pot of money in the middle between these 4 people. And all the money that every single person puts in is then multiplied, sometimes by 3 or 4 or whatever, and then paid out, and this is the important bit, equally back to all 4 players independently of how much they put in themselves. So now, why is the situation interesting? As a person, I have an incentive to just keep my 10 euros to myself, but I also hope that everyone else is going to put their whole 10 euros in, then they will triple. So that's 3 times 30 euros, makes it 90, and then we split it by 4, and I get stuff even though I didn't put any money in. That would be perfect. So the problem here is that it's individually rational for me to keep all my money to myself, because that produces the biggest payoff. But for the group, the best thing to happen would be if everyone put their money in, it multiplies, and then it's evenly distributed among all of us. So here we have some tension between how to maximize your own payoff by what we call free riding on the contributions of others, and what's actually the group goal to maximize joint payoff. Okay, and therefore this public goods game is an interesting situation. Now, I would encourage you to take a moment and pause the video and think of situations in real life that are captured by this public goods game as a model. So people don't just randomly come up with these games, right? But they're supposed to model specific real life situations. So I want you to pause and think about what situation matches the public goods game in your real life.